My name's Gregory Dale Smith. I'm the Senior Conservation Scientist here at the Indianapolis Museum of Art, and my role in the museum is to work with the conservators and curators to try and better understand the art and to better preserve it.
What training did you have to become a conservation scientist?
So my background began sort of split between archaeology and chemistry, and I pursued the two independently throughout both undergraduate and even in graduate school, going to get my PhD in analytical physical chemistry. But at the same time, I chose a graduate department that had two excavations going on in Israel, so I would spend 9 months and during the academic year working on my PhD dissertation research, but then I'd spend anywhere from 2 to 3 months in Israel working as an area supervisor on two of those excavations.
What's the biggest change you've seen in the field since you became a conservation scientist?
Our field, the conservation science, is driven a lot by instrumentation, and certainly as the analytical techniques become more and more micro-analytical, the ability to analyze just trivial amounts of material from artwork. I've worked a lot with a particular technique called Raman spectroscopy, and 10 years ago I was in a lab about the size of this office that had one instrument that took up the entire floor space. Now we have the same instrument here at the IMA, and it takes up about that much space. So certainly these quantum leaps in technology really change the way we do analysis and what we can analyze.
What do you think are the biggest challenges for today's conservation scientists?
I think challenges are the same for conservation scientists as they are for the mainstream scientists. Science is expensive, so finding funding in order to do the work that we want to do at the level we want to do it. It's certainly a challenge to be able to fund a lab, to have multiple scientists working at one location. We need our colleagues. We need to be able to develop some specialization. Most of us are generalists. We perform a lot of different types of analysis, but if you can have 2 or 3 scientists working in your department, then you're able to focus a little bit more on research and development and specialization.
Can you tell us a mistake you've made in conserving or analyzing or assessing an artwork?
Just one?
Just one.
Okay. We all make mistakes. The scientific data is incredibly complex, and so there have been myriad times that I thought I was identifying one pigment only to go to a conference, hear about something that is related, and suddenly you realize, you begin thinking back to that analysis and saying, maybe it wasn't what I thought it was. You go back and you check. So we're continually learning about the materials that we're studying, and it's particularly hard for a conservation scientist because we are usually working in all the different fields of art. So we're working with paper objects, we're working with metals, ceramics, glasses, paintings, etc. So there's a lot to know.
Do you think that a conservation scientist's work can change the meaning of an artwork?
Oh, definitely. It can change who the artwork is attributed to. It can change the understanding of how the artwork was made, the process, the technology that was implemented. So I think definitely there's a role to play for the conservation scientists to affect the interpretation of an artwork.